You're welcome back to Mr. Hassan's Math channel. This is question number 6 from the Solomon K Mechanics 1 collection. So the Solomon papers, this is Mechanics 1 M1, like Edexcel. These are like the Edexcel papers. And this is also question number 6 from my M1, Mechanics 1 endotopic worksheet, number 4 on dynamics. And here we have a question requested again by another student who wants me to answer this question, explain how to answer it. Now, figure 2 here shows a particle A of mass 5 kilograms lying on a smooth horizontal table, which is 0.9 meters above the floor. A light inextensible string of length 0.7 meters connects A to B. So that means the length of the string altogether is 0.7. So the length of the string is 0.7. These are important points here, I think, that will help us to answer the question. The length of the string is 0.7 meters. Okay. It says connects A to particle B of mass 2 kilograms. This is 2 kilograms, this is 5 kilograms. The string passes over a smooth pulley. No friction in the pulley, and also no friction on the table, smooth horizontal table, which is fixed to the edge of the table, and B hangs vertically 0.4 meters below the pulley. So this distance here is 0.4 meters. That's another important point here. That's 0.4 meters that hangs below the pulley. Okay, so there's 2 important points that we need to take into account, I think. Then it says, when the system is released from rest, show that the magnitude of the force exerted on the pulley is given by 10 root 2 over 7 G newtons. Okay, so basically, we want to find the magnitude of the force exerted on the pulley when this system is released. Now, when the system is released, we can say that once you release the system, you're going to have to consider the forces acting on these particles. Now, B is going to have its weight acting down. Okay, its weight acting down. Vertically down. So is A. Its weight's going to be vertically down. So you've got 5 kilograms, so that's 5 G newtons for A. And you've got 2 kilograms, so that's 2 G newtons for B, acting vertically down. And you've got the tension in the string here, which is up in this case, okay, which is kind of like this 2 kilogram mass is kind of being held back a bit by the A, all right, the mass A. And the mass A is being pulled this way by the mass B. Okay, so that's a tension, and because it's a smooth pulley, the tension on both sides of the pulley is the same. Now we want to find the force exerted on the pulley. Now, because these ropes are pulling on the pulley, there's a tension on this side and also on this side as well. Okay, inside the system, there'll be tension in the string going this direction and in that direction. So we want to find the resultant of those two tensions, which are perpendicular to each other, because the string is perpendicular to this part, the string is perpendicular to that part. So if we find the value of the tension, we can find the magnitude of the resultant force on the pulley. Okay, the magnitude of the force exerted on the pulley with the resultant of these two forces here. So what we're going to do here is we're going to use the equations of motion. So as I said, we have for A, we have its weight, which is 5G, and we have the tension acting in this direction. For B, we have its weight, which is 2G, and the tension acting in that direction. And if we're considering B alone, and this whole system is going to accelerate B towards the floor and A horizontally towards the pulley. Okay, those two accelerations will have the same magnitude because they're connected with a inextensible string. Okay, so let's consider the particle A. The only force acting on A, the other force is the reaction force upwards. There's no force opposing its motion because there's no friction in the system. So if we consider A, and I'm going to take this direction as positive, I can say that T is equal to M5A, because we've got the resultant force equals mass times acceleration. There's no other force except tension acting in this direction. Okay, so T is equal to MA. T equals 5 times A. And if I consider B, well, B is going to be heading towards the ground, so I'm going to take down as positive for B. And the resultant force on B is 2G minus T, and that's equal to MA, which is 2 times A. All right, so now what I need to do is find the tension in the string. So, I mean, I could eliminate the A, okay, but I think finding A might be useful. I'm guessing I'll need acceleration in another part of the question. And seeing as it's easy to find A than it is to find T at first, what I can do is I can just replace, I can add the two equations together if I want to. That will eliminate the T. Or I can replace this T with 5A. Now, if I call this equation 1 and equation 2 and I add them together, on this side you'll have T plus 2G minus T, which leaves me with 2G. So I do equation 1 plus 2. The T's will cancel out. And equals 5A plus 2A, which is 7A. So therefore I can say A is equal to 2 over 7 times G. Okay, I can leave my answer like that. All right. In fact, I should leave my answer like that because it says show that the magnitude of the force exerted on the pulley is given by 10 times root 2 over 7 G newtons. So they want to answer in terms of G. So I'm going to leave the G here. I'm not going to multiply by 9.8. Leave it in terms of G. This is acceleration in meters per second squared. Now I need to find the tension, and we know that the tension is equal to 5 times A. So we've just found what A is. So the tension is equal to 5 times 2 over 7 G, which is 10 over 7 G newtons. Now, that's not the magnitude of the force exerted on the pulley, because the pulley has a tension this way and a tension that way as well. So if you think about the pulley, if you consider just the pulley alone, so say this is the pulley, you have a force acting vertically down, the tension acting vertically down. You also have the tension acting horizontally this way. Okay, those are the two forces, and they're both the same value of T. That's T, and that's T. Now we want to find the resultant of those two forces. Okay, now the angle between these two forces, is 90 degrees. Okay. Okay, the angle between these two forces is 90 degrees. All right, so that's what we know. So that angle there is 90 degrees between them. All right, so there's two ways I can do this. The easiest way of doing this is to realize that the resultant force between two forces is always going to act, okay, if they're equal to each other, if the two forces are equal, they'll always act in a direction which is exactly halfway between those two forces. So that means that the angle between the force and its resultant direction is going to be, this angle is going to be half or exactly the same as this angle. So the two angles here, this one big angle 90 degrees is cut into two halves. So this is 45 degrees, the angle between T and the resultant force, and this is also 45 degrees between T this side and the resultant force. So what I would do is I would just say, okay, let's resolve this force in this direction. So we have to go into the angle. We have to go into the angle to find the resultant force of this in this direction. So I can say that's going to be T times cosine 45. So that's the angle in this direction here. Okay, that's the force resolved in this direction. And then here you've also got T times cosine 45 because you're going to go into the angle. So T times cosine 45, that will give you your resultant force. Okay, so the resultant tension, the result of the tension is going to be, we found what T is. It's 10 over 7G times cosine 45, which is root 2 over 2, plus another one of those, 10 over 7G times root 2 over 2. So that's going to give me, that cancels with that, leaving you with 5. And that's 5, so it's 5G root 2, okay, over 7. Okay, and there's another 5 of that, so that's 10 times G times root 2 over 7. Okay, and that's the answer, and it says 10 root 2 over 7G. That's right, so I'll just rewrite it the way they put it. 10 root 2 times G over 7 newtons. Okay, so there's the answer for the resultant of the tensions, the resultant of those two tensions. Okay, that's the magnitude of the force exerted on the pulley. Okay, the resultant of those two tensions. Now, we could have also done this in another way using vector diagrams. So I could say, let's draw the first tension. let's draw the first tension, okay, which is horizontal, and then draw the other tension, which is the same length as the first tension. Okay, and the resultant of the two tensions is going to be in this direction here. That's the resultant force. Okay, so this is T and this is T. This is a right angle, and this is the resultant force. Okay, because there's a right angle between them. So we can say that the resultant force is equal to the square root of T squared plus T squared. Okay, so that's going to give you the square root of 2t squared, which is t times root 2. And we know that t is equal to 10 over 7 g newtons. So you're going to have 10 over 7 times root 2 times g newtons. Same answer. Okay, that's the resultant force. All right, so they're both equally as easy to deal with. Okay, but this is a nice, easy way of doing it, that when you have two forces that are exactly the same, the resultant is going to be halfway between them. So if that's 90 degrees, that'll be 45 and 45. You can resolve this into the angle, resolve that into the angle, and you got your answer. Okay, so that's part A done. Now for part B. Okay, we found the acceleration is 2 over 7g. I think we're going to use that. For part B, it says find the speed with which A hits the pulley. Okay, so you know that acceleration is 2 over 7g meters per second squared. Okay, that was the acceleration. Was it 2 over 7? Just make sure. Yeah, it was. Okay, now A hits the pulley. Okay, now we know that the length of this string, as we saw in the last question, is 0.7 meters. Okay, and we also know that B is 0.4 meters below the pulley. Okay, so let's have a look. So the length of the string is 0.7. Okay, and B is 0.4 meters below the pulley. And A is 0.3 meters, okay, from this side of the pulley, because the length of the string is 0.7 meters, as I said. So if this is 0.4, what's left is 0.3 on the string. The string total length is 0.7 meters. So I know that the distance of A from the pulley is 0.3 meters. Okay, the length of the string is 0.7 meters. So that means from A to the pulley is 0.3 meters. Now, what we know in the system is we know it's accelerating in this direction, and we know the acceleration is 2 over 7g. A is accelerating in that direction, and it's also equal to 2 over 7g. We also know that it's released from rest. So let's have a look at, let's consider the particle A. You have SUVAT, S-U-V-A-T. Okay, they're both going to be moving at the same speed when A hits the pulley, but I'll just consider A. I know S is equal to, well, it hits the pulley after it's moved 0.3 meters. Okay, its initial speed was 0 because it was released from rest. Its final speed is what we have to find, and it's moving with acceleration 2 over 7g meters per second squared. The time, I don't think we need it or we have it. So we have to deal with finding the velocity or the speed with which it's a pulley. We know it's traveled this distance, we know the initial speed, we know the acceleration. So we can use here v squared equals u squared plus 2as. So you can say v squared is equal to u squared, which is 0 squared, plus 2 times 2 over 7g times 0.3, which is 3 over 10. I'll write it like that because I want to simplify this. So I've got 2, and the 10 cancel, leaving with 5. So 2 times 3 is 6. So v squared is equal to 6 over 7 5 35g. So that's what v squared is. So v, therefore, is the square root of this. So I'll take my calculator. I'll put the square root of 6 times 9.8 divided by 35. That gives me 1.2961. 1.2961. That's going to be 1.30 meters per second. You can also write it as 1.3 meters per second because you have 2SF can be used as we've used G as 9.8 in our calculation. So you can use, we're required to use, in fact, G to 2SF as the instructions are. Therefore, the answers can be expressed in 2SF or 3SF if you wish. Both are acceptable in the exam. Okay, so that's the speed with which A hits the pulley. Okay, so that's part B done. Then it says when A hits the pulley, the string breaks and B falls to the floor, falls freely under gravity. Find the speed with which it hits the ground. All right, so now what's happened is when A hits the pulley, okay, when A hits the pulley, it's moved 0.3 meters this way. Therefore, B has moved 0.3 meters down this way. Okay, so B has moved down at the point where A hits the pulley. Okay, B has moved down to here, and that is 0.3 meters extra. So the total distance here is 0.9 meters. So this is 0.7 meters. So the total distance left before B hits the ground is 0.2 meters. So it says find the speed with which B hits the ground. All right. So basically, at the point when the pulley breaks, when the string breaks, okay, when the string breaks, what's going to happen is B is going to be subjected to a force. Okay, there's no tension in the string. It's gone. You're going to have just its weight, which is, as we learned, B has 2 kilograms, so it's 2g newtons acting down. There's no tension acting up. Okay, it's just got its weight. So therefore, it's just falling under gravity, right? So if we think about it, it's just free falling under gravity. So we have S, U, V, A, T. Okay, so the distance it's got left to fall, as we just deduced here, was 0.2 meters because it starts at 0.4 meters below the pulley. When A hits the pulley, it's moved 0.3 meters more. So that's 0.7 meters below the pulley. And the pulley is 0.9 meters above the ground. So there's only 0.2 meters left for it to fall. So as it falls down under G, I'll take down as positive. S is going to be 0.2 meters. U is going to be the speed with what it had at the point when the string broke. Now, when the string broke, that's when A hit the pulley. So when A hit the pulley, okay, it was going with the same speed as B, same magnitude of speed as B. So we can say that the magnitude of the speed of B is the square root of, I'll write it in this form. So the magnitude of the speed of B is root 6 G over 35. That's the initial speed of B before, at the point where the new situation where the string broke took place. And we want to find its final speed at the point just before it hit the ground. And we know the acceleration is G. We're taking down as positive, so that's positive G. We don't have to find the time or anything. So again, we're concerned with the same equation, V squared equals U squared plus 2AS. Now, keeping things in terms of this, you'll hopefully appreciate why I'm doing that here. Instead of writing 1.30 or 1.2691, I wrote it down in terms of the exact form in terms of G and the square root. Because now V squared, well, I need to find V, so V squared equals U squared, which is basically going to be 6 over 35 G. If I square this, I'm going to get 6 over 35 G, plus 2 times A, which is G, times S, which is 0.2, which is, we can say 1/5. I'll write that as a fraction. 0.2, which is 1 over 5. Okay, 1 over 5, that's 0.2, 1/5. Okay, so now I'm going to have V squared equals 6 over 35G plus 2 over 5G. Let's just add these together. So I have V squared equals, this is 6 over 35G plus 14 over 35G. So V squared equals 20 over 35G. So now that we know 4 goes into those, 5 goes into both of those, that's 5, that's 4 over 7G. So therefore V is equal to the square root of that. So we take that, the square root of 4 times 9.8 divided by 7, and that should give the answer, which is 2.3664 2.3664 meters per second. So you can say the speed, okay, of B as it hits the ground is equal to 2.37 meters per second. You can also write it as 2.4 meters per second if you wish to 2SF. Okay, so there's the answer to part C of this question, and I think that was it. Yep, that was it. That was the end of this question. Okay, so there we have the answer to this question. Other questions from this particular paper of Solomon K. Mechanics 1 can be found in the playlist over here. Other questions from this end of topic worksheet can be found in the playlist over here. You can also click on the link here to find, in general, most different questions I've answered from different papers and from the textbooks and worksheets, okay, about dynamics and connected particles. You can find it in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.